Hi everyone, welcome to Module 5, an Introduction to Probability. So these slides were originally created by Dr. Stacy Metz, and I updated them for you this semester to make them more focused on what we need to know to move forward in the class. This module is going to introduce basic concepts and laws of probability, as well as illustrating how they intertwine with some other things we've already learned. A basic definition of probability is that it's the likelihood an event will or will not occur. In statistical terms, the likelihood ranges from 0 to 1, with 0 being a no chance that that event will occur, and 1 being this event is absolutely going to occur. These numbers are often converted into percentages instead of staying in between 0 and 1 because it makes more sense to most people. So probability percentage of 0 would be there's a 0% chance of rain. 100% probability would be if there's a 100% chance that it's going to snow tomorrow, things like that. And then it ranges in the middle from 0 up to 100%. So we hear about probabilities in like that example about the weather forecasting as well as lotteries. It's important in biostatistics that we learn a little bit about probability because the probability theory underlies much of what we're going to be talking about when we are inferring our samples back to the regular general population. So if we conduct these tests that we're going to be learning moving forward, we need to know why the samples data we have actually can be generalized back to that population. Probability is also used to compute prevalence, incidence, odds, and risk ratios, as well as the screening tests. So our learning objectives for this week or this module are to describe basic concepts of probability, random variation, and commonly used statistical probability distributions, to distinguish between the addition and multiplication laws of probability as well, to apply those to some different scenarios. We're also going to be computing a simple probability and explain the relationship between probability and relative frequency. And then we also want to apply conditional probability rules in prevalence or odds ratio and incidence or risk ratio, relative risk estimates. The final objective for today is for this module is to evaluate the utility of screening tests by computing and interpreting test characteristics, which might be positive predictive value, negative predictive value, sensitivity, specificity, false positive, and false negative estimates. A few additional reminders about this module. There is going to be a reading posted on D2L. It's a textbook chapter from Privatera. He's a really awesome author. Since we don't have a dedicated textbook, I wanted to provide this one textbook chapter to you because probability is something that a lot of students struggle with. So the chapter that's posted is really important for you to read this week, especially. And also homework 4 is associated with this lecture and that reading. So just as a reminder, that's what's associated with this module. All right, let's get started. Probability is the relative likelihood that an event will or will not occur. Again, it ranges from 0, no chance the event will occur, to 1, a certain event, that you're certain the event will occur. Oftentimes, these are converted into percentages instead of decimal places because it's easier to understand. And probability is essential for interpreting our p-values that we're going to be relying heavily on moving forward in the course, as well as calculating sensitivity, specificity, and predictive values of screening tests. Probability is symbolized with this letter P that I'm drawing. So it can either be a capital or lowercase p. And it is the frequency of times an outcome occurs divided by the total number of possible outcomes. Another way for probability to be described is a measure of the likelihood of observing an outcome in a random event. So probability, an important thing to remember, is it can never be negative. So probabilities are always positive values, and they're always between 0 and 1 or 0 and 100%. So the likelihood of an event that we're going to call A, so the probability of some event, some outcome, A, would be symbolized as P and then in parentheses A. And this is also what's written in the first bullet point here. So probability of A happening, if there's no possibility that it's going to happen, the probability of A would be equal to 0. So the probability that you're going to have no homework assignments in a class is 0. You'll always have some sort of homework type assignment. If there's some possibility that an event's going to happen, the probability would be 0 less than the probability P of A. I know the writing on this isn't super great, but I want to write it out for you. Is less than or equal to 1. So again, this is what is written up here. So the probability of an event happening, so some sort of probable event, but with a likelihood of between 0 and 1 would be signified by writing 0 is less than the probability of the event A is less than or equal to 1. Sample space is the set of all possible outcomes, so it's oftentimes also referred to as outcome space, and it's the total number of possible outcomes that can occur in a random event. So the probability of P of an outcome, X, is representative by P and then in parentheses X. So this is similar as the last slide where we were having the probability of event A. And then the frequency of the number of times of an outcome is representative by an F and then in parentheses that event or outcome X. And then the formula for probability is the frequency of the number of times that X occurs or some outcome occurs divided by the sample space. So I'm going to abbreviate that as SS here, or the total number of possible outcomes. This will make more sense when we have an example, but there's some examples relating to birth on this slide. So for example, a birth of one child, there's 2 possible events or outcomes. They're either going to be born as male or they'll be born as female. In the birth of twins, there's 3 possible outcomes. There could be 2 males born, there could be a male and a female born, or there could be 2 females born. And another example in genetics, if both the mother and the father carry a copy of a recessive disease causing mutation, a lowercase d, there are 3 possible outcomes in a child. Either the child is not a carrier, so they got both of those dominant genes or capital Ds. The child is a carrier, so they would have a capital D as well as a lowercase d. And the third option would be the child has the disease, which would be the 2 lowercase ds. Since both the mother and the father carry 1 copy of the disease, they're both carriers. They may not have the disease themselves, but they carry it, and their child has those 3 possibilities. The basic rules of probability are that the relative frequency is an approximation of probability. So the relative frequency of an outcome is the same as the probability of its occurrence for any given event. In this example, the probability of a coin toss of heads you would repeat the procedure of tossing a coin multiple times and then find the ratio of the number of times the coin landed heads up. So let's say that was 10 times the coin landed heads up to the total number of tosses, and let's say we did 100 tosses. The probability in this example would be 10 out of 100, or 1/10, or 0.1, sorry. The second rule is the classical approach to probability. This requires equally likely outcomes. So here, the example of using a die, of getting a 1 when you roll one die. So instead of rolling 2 dice, we're rolling 1 die. That's the singular form. I know it's a little weird looking. So the probability of rolling 1 with 1 die. Well, we have 6 faces on our die, so they all have an equal chance of getting landed on when we roll. So the probability of getting a 1 would be equal to the number of ways 1 can occur divided by the number of events. So if the dice has 6 sides, there are 6 events, and there's only one way that 1 can occur. So the probability of getting a 1 when rolling a die would be 1 out of 6. And the last rule, that's a basic rule, is the subjective probabilities. So this is talking about what's the probability of it raining tomorrow, or what's the chance that it's going to snow next week. And here's where you would use your expert knowledge as a meteorologist to develop some probability estimate. This is less relevant to what we'll be discussing, so I don't give a lot of example on it. It's just, as you, I'm sure, know about weather predictions and things like that, this is the type of probability they're using.